Hi, everyone. I'm Hunter from GovTech, and I'm a distinguished engineer. Today, I'd like to talk about what's new in GCC 2. A little background about myself first. I'm a distinguished engineer who spends a lot of time thinking about cloud and engineering strategy for GovTech. I'm a member of CODE, the community of distinguished engineers. And I also head up the cloud engineering team, which is really a group across GovTech that is established to improve the GCC platform. So, the topic for today is really around what's new in GCC 2. And today we're going to go into a little bit more of a technical dive, talking about what we see and what we think about when we are looking at GCC and the differences from our original environment. So, if we look at GCC as a framework, we have 4 really key components that we talk about. We have the cloud management portal, which is really around onboarding and billing. We have our monitoring, logging, and jump host, along with governance, policy, and data residency. And finally, the network connectivity, especially back to on-prem. We've got these 3 key elements, all of which sit on top and around the CSPs and the applications that are being developed. Now, from GCC 1, we got a lot of feedback, and we ran a number of satisfaction surveys to understand the feedback, and we really took those away and used them as learning points. And some of those things are around how slow it was to onboard, and that there really was this wish to be able to access more cloud native tools and to utilize more automation to really make the most of the use of the cloud. And so as part of that, we really had to start rethinking about our operating models. From what GCC 1 was and what we have typically known in government, it's been a managed hosting environment. What we think about as being waterfall, about being outsourced, all of these sorts of things really needed to rethink to what we sort of call DevOps culture. These things around agile, having some ownership in-house, being fundamentally about self-service automation and the use of cloud as a native experience. So much of this really came down to how we started to evolve and rethink about our operating models as we started to look at the next generation of our cloud platforms. What we really started to think about was that sort of vision that we came as part of that. So, there were 3 really core pieces of that we looked at. One of those being cloud native, the other one being self-service, and finally the automation. All of those sorts of things that we saw as feedback became key drivers for our vision of GCC 2. Now, as part of that, really what that meant was a refinement of that framework that we just had previously. And we'll come back to this as we go through today. So much of it is about refinement. It's about taking what we had as an existing piece in GCC 1 and improving on those, making it more efficient, making it lighter touch so that agencies could deliver applications with more flexibility and more control. So we'll go into a little bit of detail about how we started to enable that. So the GCC platform itself is a really fundamental core. So we wanted to really evolve the platform to really build out a strong base that we could enable these sorts of things for our vision. One of those is a landing zone. Now, landing zone is a standard piece that you see used across all the 3 major CSPs, AWS, Azure, and GCP, as a way of consistent and repeatable account provisioning. As part of that, our cloud management portal really needed to be simplified to really get out of the way so that we could leverage the strengths of the CSPs and to adopt those sorts of things that we consider to be cloud native. And finally, one area that was sort of raised as an impediment was accessing servers and workload administration. Cloud native jump hosts became a really key component of that. So we started to look at how we could enable that in a secure manner. So the first piece was really thinking about how we established a landing zone. Now, a landing zone is the foundation of cloud environments at scale. at the scale we see in government, it really needs to be both repeatable and a means of providing, you know, a certain element of transparency and configuration for agencies to be able to get access to their accounts and to provision it in an easy and quick manner. Now, those sorts of things become an enabler for things like speed and confidence, repeatability and transparency. So, you know, these areas we start to see as being enabled from a landing zone is really the governance and the onboarding, the networking and security. So the tool of choice was really Terraform to start to enable that, partly because all the 3 CSPs actually have landing zones built in Terraform. Now, you know, Terraform itself is a language that provides its language consistency, even though the implementations may be different across the CSPs. And finally, this is a real key piece as we start to look at the ability to take this code and share it with various different teams across government so that they can learn and collaborate on this platform as well. Importantly, we don't want this to be something that is hidden and developed in private. We want agencies and the developers who are working on it to co-create with us, to create the best environment possible and to build out the best sorts of landing zones. Now, a key piece of a landing zone is really the account vending, as they call it, the provisioning of these sorts of accounts based on requests. Now, this diagram that we have here really shows the workflow that comes from the AWS flavor of landing zone. And this starts to tie in various different pieces about aggregated billing, connection to shared services accounts, security accounts to make sure that we're doing centralized logging, we're making, you know, changes that are visible, auditable, and secure. And finally, these sorts of things come together into an account that is then handed over to the agencies to be provisioned in any environment or any way that they see fit. It could be more Terraform, and we provide, you know, enablers for that. It could be CloudFormation. It could be manually created. It's entirely up to the agencies. But what this account vending machine does is sets up this framework that we can apply these sorts of automation. And it's a very critical piece as we start to scale, especially at the sizes that we start to see in government. Now, as part of that, that also comes down to the fundamental principles about how we enable this landing zone. Now, landing zones are just Terraform code. So we need a consistent process to apply these sorts of changes. And so for anyone who's familiar with the DevOps process or GitOps, this is very much an enabler of how we follow the same processes. So we want to have a consistent means of deploying landing zone code, IAC, the code for the cloud management platform, the code for various different platform tools that may be exposed in CSP, along with these sorts of pieces of documentation. We want a similar process, partly because it means that we can have strong change management, which gives us the agility to start to make these sorts of changes very, very quickly. So the use of Git as a tool, the use of pull requests to be able to review these sorts of changes and to audit them, both by automated tests, but also by key members of the team to make sure that these things are in alignment with both our security policies, our development guidelines, and our processes as well, alongside of CI/CD for managing the deployment. And so this is a universal process that we can use across the GCC platform, the deployment of accounts via the account vending machine, the applications that make up GCC themselves, and it's also something that we then recommend for various different tools that are aligned with that, the ship platform, the deployment. And interestingly, when we talk about this as a universal process, this also covers off design documentation, about audit material. All of these sorts of things come under the same place. So it became a very important piece that we started to frame and discuss. And so in many of our discussions, we pulled in the audit teams, the internal audit teams, to see how this would work as means of a process that can be adopted and accepted. And it was something that we got external reviews in as part of as well, and became a very fundamental piece about, you know, for the acceptance of this and the adoption and the driver for managing change across GCC and the various different applications and platforms that we build out as well. So the cloud management portal was another key piece. And I think this is something that, as I mentioned earlier, we want something to be, a fairly simple onboarding process. We want to really get it to a point where accounts are being handed out and sent across to that account vending. And then really, getting out of the way as much as possible. Now, that's not always entirely possible for the different classes of users that we have in GCC. So, while we have these fairly advanced users who are comfortable with automation, we want to encourage that self-service in the CSPs. But we want to make sure that these sorts of things get built in for agencies who may not necessarily be as comfortable or may have different requirements, so that these managed workflows can come into play. And so we'll talk about a little bit further on about how we do network automation, enabling these sorts of things with the flexibility for agencies and the developers to choose. The cloud management portal became the key entry point so that people and agencies could onboard into GCC, and then to get accounts in their various different CSPs, and then to provide the control and configuration if needs be, along with the billing and the other pieces too. So the other area that I mentioned earlier on is the workload administration component. Now we wanted to take, again, a very cloud native approach to this, enabling the CSP jump hosts, tools like AWS Systems Manager Session Manager, which is a little bit of a tongue twister, Azure Bastion and GCP IAM with its SSH connectivity built into the portals there. So this is a very key piece for most typical workloads that aren't necessarily sensitive. So we have also another connection there with the PIM common servers for those sorts of workloads that may need more advanced recording or session management or other aspects there. But the key piece was a default reliable piece, because a break glass account, which workload administration typically is, must be more reliable than the services that it is serving. So it became a really critical key piece there. Now, security in governments is always an important part, especially in government. So, and going back and aligning with the sorts of visions we see, going back towards being light touch, enabling these sorts of end-to-end automation entirely in the CSPs, if chosen that way for the agencies. Policy as code, rather than blocking features, providing detective reporting to know when things aren't necessarily in compliance or doing things in the right manner. And these sorts of things are enabled by AWS config, Azure policy, and these things can be scaled out from one agency across the whole of government using the landing zone. And finally, these sorts of self-service networking, which becomes a really, really key piece, especially around the automation of VPCs, of transit gateways and peering. So going into a little bit more detail, policy as code becomes that a critical piece that monitors all sorts of changes inside the CSP. Now, this process is fairly typical for AWS, but is also very applicable to Azure policy and other pieces across the CSPs. So recording these sorts of changes, validating it, making sure that they fit into various different compliance benchmarks and security controls that we may need to put in place, because we are taking elements away and giving more control back to the agencies and their developers. Managing networks is such a fundamental piece, and so much of what it was in GCC 1 was about controlling these elements, which may be very limited resources or important resources. IP address allocation is always such an important part, because IPs are generally limited, so even inside of government without private address spaces. Network peering is also a potential security risk, so we needed to be able to manage that, but also balance it against the needs for self-service and security. So GCC 1 was typically managing IPAM, the creation of VPCs, the compartments, and the peering with service requests, which made it very, very difficult to do automation end-to-end. Important controls there, but we wanted to think about it with a little bit more control for the agencies. So we wanted to enable automation and self-service. And so there's a critical key piece there is things like IPAM to manage the IP address allocation. But we wanted to enable with APIs, IAC or through the cloud management portal, but allow much more control about VPCs, peering of transit gateways or connecting of transit gateways, and these sorts of cloud CSP native workflows. So we put in a number of policy as code checks to ensure that these sorts of things are put in place. Tagging is another really critical piece, so that all of these sorts of VPCs need to have tags, and then the policy as code follows to make sure that they're not doing anything that's risky, like applying an internet gateway to an intranet compartment, for example. So these are the sorts of things that are put in place to minimize the risk, but still give us that speed and time to market. So the final piece that we start to see is, how do we access GCC? Now, I'm going to cover this at a fairly high level because the other sessions in this track are actually going into much more detail and can explain it much better than I can. But just at a very high level, there are a number of challenges with connecting to GCC and the number of accounts and the network access to these various different services. And so what we see really is, how do we make this simpler? How do we make it more effective and efficient? And so we really came and wanted to learn from the industry. And so later on in our sessions in this track, we'll be hearing from both Microsoft and Google about various different aspects of their solutions to understand what's happening in the industry. We took a lot of those learnings and applied it to what we call SEED. Now, SEED is for securing developer endpoints. It consolidates around our TechPass platform for identity for both vendors and public offices. It also covers Deep, our real-time endpoint security platform, and also an identity-aware proxy aligning with sort of zero trust principles to enable access to GCC and the various different engineering solutions that we see in the Singapore tech stack. So finally, really what this starts to look at, and we do have a bit of a comparison here between what GCC 1 looks like and what GCC 2 does, is we've significantly simplified the identity and access control portions for GCC. There's a single identity as a public officer with a whole of government identity, or as a vendor that's been assigned into TechPass. There's a number of pieces around conditional role-based authorization, access control that are being provided by these various different components that make up SEED, this blue box at the bottom, and then providing access into the cloud management portal, the various different CSPs, or the Singapore Tech Stack engineering services. So it became a really critical piece to help consolidate identities and to accelerate access into the GCC services. So really just a quick cap, what's new in GCC 2? On the left-hand side, we've seen both the CMP and SEED helping enable faster onboarding. We've got cloud-native jump hosts to improve connectivity and the ability to log into our servers. On the right-hand side, the improvements to networking to enable more self-service with policy as code to help enforcement and checks. And finally, at the bottom, the landing zones and the policy as code elements that fit together into the GCC platform to cover off the various different elements that we've refined as we build out GCC 2.0. So I would like to end that there and to say thank you to everyone. Very happy to get lots of questions to dive into a little bit more depth. So thank you very much and enjoy the rest of the track. Thank you.